Good afternoon to all. You are listening to Radio Jattana 107.8 FM. I am Dr. Kamali Singla, working as professor in Department of Computer Science and Engineering. Today we are fortunate enough to have in our studio a very learned, very experienced man who is amongst the top 100 learned scientists in India and is the pride of the nation. He has made significant contributions in the world of space and research. Yes, I am talking about none other than Shri H.S. Jattana ji, who is a retired scientist in Department of Space, Government of India. To be precise, Shri H.S. Jattana ji is presently an adjunct professor of microelectronics at University of Pune and faculty at PGIMER. He is having a very vast experience in VLSI technologies. So stay tuned with our live conversation and keep listening to Radio Jattana 107.8 FM. So my first question is, we all know that entire world is running towards UN-led sustainable goals. So how the space research can contribute in sustainable living on Earth, and what significant contributions India is planning to make in this direction?
See, space technology and space applications, they have a wide range of applications in all spheres of the economy, of whether it relates to our social thing or education or medicine. As you are talking about sustainable growth, so this means, first of all, the space applications can provide you a very efficient way of organizing any business or doing anything. For example, I will illustrate giving one example. A question of say a drinking water. So we try to dig around maybe some 70 feet or 100, 200 feet of earth from the earth's surface and see whether the water is of adequate quality, drinking quality or not, and of maybe for agricultural use or not. And if we find it's not, then we go to some other place, dig it like that. So a lot of resources are used. So a lot of in that manner you are using a lot of fuel also, a lot of diesel, which creates pollution, which and end result is not successful, is not like it's a failure. End result is not successful. So now space application can tell you with, I think, a probability of 90% that these are the coordinates. You go there, you dig there. Their chances of finding a potable, drinkable or agricultural use water is 90% probability. So that way you are saving on time, you are saving the planet from pollution, because now the serious question is the pollution. And pollution is not only air, it is on the earth, it is on the earth's surface is polluted, water is polluted, air is polluted, and it affects the entire thing, not only the health, even the economy. So sustainable growth will only come if we are able to control the pollution, particularly the waste. Now, how much waste is being generated in big cities, and we have seen outside Chandigarh there is a big mountain, outside Delhi there is a big mountain. So how to address those waste? So how to control that waste? So in that, the space technology has applications. Then another, what is inside the earth's crust? What is inside the ocean? So space application can tell you to a good amount of accuracy, 80-90% accuracy. And not only that, it can tell you the crop yield also. Like now, before harvest, much before, say 2, 3 months, 4 months before, when you have put the seedlings, if you take a picture and you can tell how much area is under harvest and what is the growth of the plants and how much yield will come. In 3 months in advance, it can tell the government. So the government can plan there. If there is a shortage, they can see what to do and things like that. It can, a lot of, we have in India, there in the southern states, there is a dense forest, but in countries which are big like South America, North America, South Africa, there are big forests. And there are forest fires which can go on for 3 years, 4 years. And you can see how much can they spoil the atmosphere and and they will affect the wildlife also, and how much they can spoil. You cannot control a big fire in a forest, but the ignition point can be known by a space technology, so that you can control it by helicopter, take the water and put it and stop the fire there itself. Once it spreads beyond a particular limit, it's very, very difficult. And same is the case of we have oil wells in northeast regions to protect them from the fire. So starting point can be corrected. So there is a lot of applications. These are just few I have named, and which have so space technology is playing a very important role in the sustainable growth of the in all sectors of the economy, not only one.
Okay, thank you, sir. Sir, besides these significant achievements, what recent advancements we can witness in near future in the world of semiconductor technologies, and what kind of change it will bring in our day-to-day life?
Semiconductor revolution is another which we have seen in the last 30-40 years, how they have changed the way we work, the way we live. Because whatever we do, all this automation, all this AI ML thing, they are basically dependent on a very, very fast processors which are made using silicon as a semiconductors. And now not only the silicon, there are other substrates like gallium nitride, gallium arsenide people are targeting. There are a lot of applications. Lightning, all of us we have seen, that is an aluminium gallium nitride, all GaN. So all of us have seen in the last 10 years how this lightning technology has changed. So we have the bulb, which is a LED bulb having a wattage of 9 watt, 10 watt, but luminous is same, which used to be of a 100 watt filament bulb. So you are saving 80% of the power, 80% of the energy for the same light. So semiconductor, there is a revolution, there is a lot of work in multiple areas. Based on silicon, we are continuously trying to reduce the channel lengths. Their 5 nanometer channel lengths are in mass production, and companies like Intel, they are trying to focus on 3 nanometer, 2 nanometer, and there is a lot of work going on for compound semiconductors, binary compound semiconductors, ternary compound semiconductors, silicon carbide, gallium nitride particularly. These are required for electrical transportation, electrical cars, electrical buses, electrical trains. So these where silicon chips cannot be used, there these AlGaN devices can be used. So in India, the government is trying to get some manufacturing, because right now we don't have mass manufacturing. And the total market, if you see, of the semiconductor devices is more than $800 billion. And India's share, as we don't have any commercial activity, is zero. So we import a lot of things. All these systems, they are made of silicon chips. You name any laptop or a mobile or a PDA or any gaming thing. So all they have silicon chips, and all we are importing that. So the government is trying to create some manufacturing bases in the country. Maybe in the next 3-4 years, some bases might come, and lot of opportunity for the people. And presently even there is a shortage of manpower in the semiconductor thing. That is the reason why big companies not interested in creating manufacturing bases, because they say when India doesn't have the required trained manpower in this particular sector. So if they have to get a trained manpower from Singapore or America, so there is no point in making factories in the country when there is no. And the government is trying to create around 60,000, 70,000 trained manpower in semiconductor in the next 5 years at all levels, graduate, postgraduate and doctorate, because all levels are required for this particular thing.
So you are indeed a very learned person. You have developed more than 200 VLSI products for space applications. Kindly share one such experience about your one prominent product that you have developed for any of your application.
Yeah, you talked about the prominent. That prominent is a Vikram processor. It's a 16-bit processor and a 32-bit processor. It is used in the rocket for control of that. So that processor, ISRO, we were manufacturing abroad at Atmel. Atmel was the company, because these processors which are used in rocket, they are space grade. They are radiation hardened, in the sense even if radiations fall, they will not malfunction. So we designed that processor, we manufactured that, we fabricated that within India in our plant in Chandigarh. We tested that, we qualified that, and we space qualified, and we put it in the flight, and it has been successfully going in the flight. And this is one. Another is, there are likewise, another is a CCD, which is imaging devices which are used to take images from the space. So those technology also, charge coupled devices, Those technology also were developed within India. So we designed it, fabricated it, characterized it, qualified it, and finally put it in the satellite. And the quality of the images, resolution wise, was exactly whatever we had planned. So likewise, there are many analog circuits, 16-bit ADCs, 12-bit ADCs, some DACs, some LDOs. So there are many devices which we have done, and they are being used in rockets and satellites also.
Okay. So what is the probable future of drones and remote satellites?
Yeah, remote satellites future even now is tremendous. There are so much applications. Weather forecasting, everyone, we all of us know. So we can know what will be the water in a particular river in advance. You see, every day in the morning, the ISRO gives information to the fishermen in the coastline that we will give the coordinates, that go in that coordinate, the fish density is more. So that is possible by using space technology only. So there are numerous applications in all spheres. Drones are catching up. They are basically small, lightweight aeroplanes with pilotless. There is nothing of that sort. So they will be, I think, they are very, very useful in an area where you cannot go with a light combat with a light aircraft which is manned by a person, which is manned, where there is a danger to his life. So instead we use a drone in those areas. It will be quite helpful, like in a where there are big mountains, mountainous areas. There are a lot of peaks, mountain peaks, very difficult to fly a plane. So if you have to do some activity there, surveillance for activity, so drones can be used, and for surveillance they can be used for transfer of material also in advanced countries like US. So people have successfully demonstrated that drones can be used by the courier companies for dropping the packages on the rooftop. So there will be, as the drone technology matures, so number of applications will be found. Now we have drones which can take more load also, and drone technology is day by day in advancing. So it will generate lot of even jobs also, and lot of other applications.
So my next question is dedicated to all my engineering graduates, and on behalf of them I'm asking this question: what preparations they should actually do during their graduation tenure to become a space scientist?
You see, space technologies involved around 17, 18 different disciplines like aeronautical, mechanical, electronics, computer science, then your explosives, chemistry, physics, maths, everything. So here, if you have to solve any problem, that is not confined to knowing a particular thing. Even if you have to make bridges across rivers like Brahmaputra, it's not only a civil engineering. There are other. It's a integration of various these engineering branches of engineering and even the science. So here, what I feel is, to be successful in life, it is important to understand the basic concepts of science, basic concepts of technology. That is very, very important, which I feel most of these students, because it takes time to understand these concepts, they try to skip. They find two shortcuts. So there are no shortcuts. And I have seen when we were studying, we used to have around 17 or 18 courses in mathematics. Whatever is taught in MSc Maths, we have studied in BTech even, and around 7 and 8 courses in physics we have studied, because that is basically the foundation. And now people are skipping that, and because industry also want industry trained, that is not the job of the university to make industry trained manpower. And in ISRO, that is not the culture. Once we take ISRO recruits some person, we need a person who has very good understanding of the basic concepts, and we have a 6 months, 1 year elaborate training program within the job, and we will train them. And so I think the focus should be on basic concepts, and then only, and what we are churning is basically a white collar laborers. They know a particular skill, and they are using that. And as you know, technologies are changing, everything is changing, skill set is changing, and once that skill is over, then there are no takers for that.